Before watching the video, do subscribe my channel and hit the bell notification icon to get the instant updates.
We'll discuss graphical representation that is related with the effect of pressure by keeping the temperature to be constant. Effect of pressure on adsorption at a constant temperature. Okay? So if I talk about the adsorption with respect to pressure, it is favorable at a low temperature. So temperature I have kept fixed, but the pressure, as it increases, the adsorption would be higher. Now here the amount of the adsorption is represented by a ratio X by M, where X is the amount of gas adsorbed on the surface of adsorbent and M is the mass of the adsorbent on which the gas is adsorbed. So basically I had said that in case of adsorption, occlusion is the most common process in many of the reactions. Occlusion was what?
The
gas molecules getting adsorbed on the surface of the solid. So X is the amount of the gas which is adsorbed per unit mass of adsorbent. And this X by M actually refers to the extent to which adsorption is being done. So X is the amount of gas adsorbed per unit mass of the adsorbent. For simple example, generally this reference of the adsorbent is taken as charcoal and the amount taken is 1 gram. And then different gases are analyzed. Whichever adsorbs more at a higher pressure, it will have the extent of adsorption which is high. Okay? So let's say I have 3 gases, sulfur dioxide, methane and hydrogen. All the 3 are adsorbed on 1 gram of charcoal, which will be adsorbed to a higher extent, SO2. The reason was? Dipole-dipole interactions tha, but the extent of adsorption depends on
intermolecular force of attraction, so they can get closer to each other.
Correct, and that was related to the critical temperature. Because critical temperature actually is related with the easy liquefaction of the gases. The gases which will be easily liquefied, they will also get easily adsorbed. So SO2 adsorbs to a higher extent, followed by methane, and the least will be hydrogen because of its non-polar nature. Okay? So coming back, X by M is the ratio indicating the extent of adsorption, meaning the gas which is adsorbed per unit mass of the adsorbent. Okay? Now this X by M is related with pressure and it should be directly proportional. Now there was a scientist who carried out this relation and the name was Freundlich. And the graph which we are going to understand is called adsorption isotherm. Adsorption isotherm. Why isotherm? At a constant temperature. So we have different conditions which are named with respect to iso. Just a constant temperature is isotherm, constant pressure isobar, constant volume isocore, and constant heat is not allowed to exchange. Adiabatic. These 4 processes are very important. Isothermal, constant temperature; isobaric, constant pressure; isocore, constant volume; and adiabatic is constant heat, meaning the heat is not exchanged with the surroundings. The amount of the heat content always remains constant. Okay, so the Freundlich adsorption isotherm gives you a graph of X by M, that is the extent of adsorption versus the range of pressure. Clear? And the graph, when he observed by experiments, it was observed like this. Now to understand the graph, I'll just break down this into 3 parts. First, second and third. So I will just name this as OA, AB and BC. Now in OA region the pressure is low. In the BC region the pressure is very high. And this I can consider it as average. Clear? Now in the low pressure region the amount of the adsorption would be lesser. As the pressure increases, the extent of adsorption also increases. How they are related? Directly proportional. So case number 1, in the low pressure region x by m, can I say is directly proportional to p raised to 1? It's proportional to p. It's of the form y equal to mx. Correct? Now, third case pehle lete hain, that is high pressure region. If the pressure applied is extremely high, what do you observe? It's constant. In BC region, the graph is having a line parallel to the pressure axis, meaning however high pressure you may apply over a particular time or the point B, the adsorption is going to be constant. Clear? So how can I write the expression under the high pressure region if it is constant? What is the mathematical equation? Yes.
P raised to 0.
P raised to 0. Matlab it is constant, na? So I can write x by m is actually a constant, but in terms of pressure I can write it as P raised to 0. Now when the pressure is average, neither very low nor very high, you can see the relation is increasing, but it is not linear. It is not linear, it is exponentially increasing. So at a very low pressure, we say the adsorption is very less. As you increase the pressure, the extent of adsorption is increasing. Further increase in the pressure will increase the extent of adsorption, but not linearly, exponentially. So I can say in the average pressure, I can write x by m is proportional to P in the range 0 to 1. Clear? When it is 1 से less, it will be exponential. जैसे जैसे 0 को reach करेगा, it will become a constant. Clear? So summarizing this 3 as a general equation, x by m is directly proportional to P raised to 1 by n. It's given as x by m, extent of adsorption, is proportional to P but raised to a power 1 by n, where 1 by n can have the values ranging between 0 to 1. So it can be greater than or equal to 0, less than or equal to 1. So 1 by n equal to 0 हो जाएगा, तो in that case high pressure region आएगा. 1 by n 1 हो जाएगा, तो low pressure region. If it is between 0 and 1, it will be average. So it's given by a power which is indicated as 1 by n. So therefore I can write x by m is equal to k times p raised to 1 by n, kp raised to 1 by n, where k and n both are constants. And these constants actually depend on the nature of the adsorbate and the adsorbent. Nature of the adsorbate and the nature of adsorbent. Meaning, nature of adsorbent we can relate it with the surface area, porous nature. Nature of adsorbate we can relate with the ease of liquefaction of the gases, which is related with the critical temperature, or in case of chemisoption we can relate with the reactivity of the adsorbate. Clear? So this k and n are the constants which will be dependent on the nature of the adsorbate and adsorbent. Clear? So in short, Freundlich adsorption isotherm is a graphical representation of the extent of adsorption versus pressure at a constant temperature. Mathematically is given as x by m is proportional to P raised to 1 by n, where 1 by n can range between 0 and 1. So based on this relation, I can divide into 3 parts: low pressure region, high pressure region, and low pressure region, average pressure, and high pressure region. Under low it is linear, high pressures it is constant, average it is exponentially increasing. Clear with that? Okay, now to validate the Freundlich adsorption, we actually take the logarithm form, and in calculations, if that logarithm form satisfies, then we can say Freundlich adsorption isotherm is valid for that particular experiment. Okay? So I'll just take this mathematical equation: x by m equals to kp raised to 1 by n. Apply logs on both sides. So this will be log of x by m is equal to, multiplication has, so I'll get log k plus log of p raised to 1 by n. Now this power I can bring down and I can write log x by m equal to log k plus 1 by n log p. This is to the base 10, this is also to the base 10 and to the base 10. Clear? So now if through the above equation I plot a graph of log x by m versus the log of pressure, what will be the graph like? I am plotting log x by m versus log p. Application of mathematics, nothing more than that.
So first it will be a straight line, then it will come down.
Straight line and will come down. No.
So ये पहले वन है फिर आप भी आता है 0.
Listen, log x by m I have plotted on what axis? Y. So can I replace it by y? Log of p I have plotted on? So I will replace it as x. Can you see the relation? Y equals to mx plus c. As simple as that.
So we take log k का intercept.
Perfect.
And then slope is
Positive or negative?
positive.
Positive. So it will be increasing.
Increasing.
Clear? Y equal to mx plus c, it's a slope point form, and if the slope is positive, it will be increasing line with the y-intercept, and if the slope was negative, it would have been decreasing with a negative slope. Okay? So here there will be a y-intercept, and this y-intercept ka value will be equal to what?
Log k.
Log of k. Just compare y equal to mx plus c, जो ऊपर लिखा है. बराबर? And then as we increase the pressure, it will go on increasing, and the slope will be given by 1 by n. Clear? So validation of Freundlich adsorption isotherm is better with the logarithm form. So this form is actually difficult to analyze, but this particular form will be easier in terms of calculations and other things. Clear with that? So that's about Freundlich adsorption isotherm. Just one more thing. In this case, I had taken the case of occlusion, where there were gas molecules adsorbed on the surface of a solid. Correct? If instead of the gas, I have a liquid, then I'll not take the case of the pressure, because liquids and solids do not have appreciable effect of the pressure. So in case of a liquid, what parameter needs to be considered?
Surface tension.
None. Temperature is constant, isothermy, volume. But we don't take the volume, rather than volume, we also consider the moles and volume together. What is that ratio called? Moles by volume? Concentration. Moles per unit volume is simply the concentration which we had indicated in equilibrium chapter as square brackets. Right? So, in case of solutions, the same thing is valid, but instead of the pressure, I'll replace it by what? Concentration. So, x by m is equal to k into c raised to 1 by n, where c here is the concentration of the solution. Clear है ये? समझा? तो generally we represent for the gas in solid, but if there is a solution, we'll just modify it to x by m equal to kc raised to 1 by n, and all the other details remain the same.